Добрый день.
Dear ladies and gentlemen, dear colleagues, dear guests, let me start the Dissertation Council session dedicated to the defense of dissertation of Anastasiia Zvereva, seeking the degree of the candidate of geographical sciences in the specialty 25028, Oceanology, on the topic low-frequency oscillations in the Sea of Japan. According to the guidelines of St. Peter's State University, I, Zakarchuk Evgenievna Alexander, Doctor of Geographical Sciences, Professor, Head of the Department of Oceanology of St. Petersburg State University, is vested with the position of the Chairman of this Dissertation Council. The Dissertation Council also includes Tatiana Vasilyevna Belanenko, Doctor of Geographical Sciences, Professor of the Department of Oceanology at St. Petersburg State University, Leonid Yosifovich Lobatukhin, Doctor of Geographical Sciences, Professor of the Department of Oceanology at St. Petersburg State University, Alexei Vadimovich Zimin, Doctor of Geographical Sciences, Head of the Laboratory of Geophysical Border Layers, Institute of Oceanology, named after Shirshov, the Russian Academy of Sciences. In the remote mode, we have Igor Valentinovich Polikov, Doctor of Physical and Mathematical Sciences, Professor of International Arctic Research Center at Atmospheric Sciences, Department of Natural Sciences and Mathematics, University of Alaska, Fairbanks, in the USA. According to the federal law of 2308-1996, number 127 on science and state scientific technical policy, St. Petersburg State University is entitled to grant its own degrees. According to the order of granting degrees in St. Petersburg State University, and based on the other guidelines, we are holding this Dissertation Council. According to the regulations of St. Petersburg State University, the Dissertation Council should have no more than 4 people. Our Dissertation Council has 5 members. 5 members are present, including Polikov Igor Valentinovich, who is on a remote link with us through Skype. And I would like to outline the procedure. The whole Dissertation Council defense the Viva will take place for 2 hours, no more than 2 hours, and it includes a short presentation of the chairman about the procedure, 5 minutes, then number 2, a short presentation of the defendant that outlines the core tenets of the dissertation, 20 minutes, questions to the defendant on the basis of the content of the presentation, no more than 2 minutes per question, and answers of the defendant. Then the chairman will read out the reviews from outside institutions and those members of the Dissertation Council that have been uploaded on the website of St. Petersburg State University. And number 5, 20 minutes. Then the defendant will answer questions and critiques, not more than 15 minutes. Then open discussion. The floor is open. The registered participants of this dissertation from the audience will have the right to ask questions. No more than 5 minutes minutes per question. And number 7, the final answers of the defendants for the questions to address the questions that have been asked, no more than 5 minutes. Then number 8, the academic advisor will speak for more than 3 minutes. Number 9, there will be a break for 5 minutes for the discussion within the Dissertation Council on the verdict. Then number 10, and then in the duration of this break, the broadcast is switched off. Number 10, open voting procedure and the counting of the votes by the chairman of the Dissertation Council and putting this into the registry. And then number 11, the verdict on granting or non-granting the sought degree is going to be taken. And then number 12, the defendant will have 2 minutes for a final word. And I would like you to switch off the mobile telephones, and I appreciate your consideration. I would like to also note that the simultaneous interpretation from Russian into English is provided, and the live broadcast is also provided and is carried out on the website of the university. And I would like to now get to the main part of our session, the dissertation of Anastasiia Evgenievna Zvereva. It has been accepted by the Dissertation Council, chairman of St. Petersburg State University, and stipulated in the decree, in the Act of St. Petersburg State University on dated 13/07/2017, number 7607/1, and the dissertation seeking the degree of candidate of sciences in the specialty 250028 oceanology on the topic low frequency oscillations in the Sea of Japan is accepted for defense. The defendant has presented the following documents: personal application addressed to the rector of St. Petersburg State University, Professor Nikolai Mikhailovich Kropachev, a copy of the document of first degree, the document that certifies that all the candidate postgraduate examinations have been passed. The review of the academic advisor, Viktor Robertovich Fuchs, Doctor of Geographical Sciences, Professor of Department of Oceanology, also submitted. Then the list of publication numbering 16 has been, and then dissertation in both Russian and English. And now I would like to give the floor to the defendant for the presentation. Dear ladies and gentlemen, dear everybody present, I would like to present my presentation for the defense. Conclusions made about the presence of, despite the fact that a large number of publications are devoted to the description of the variability of oceanological fields in the Sea of Japan in the range of international, seasonal, and synoptic timescales, the dynamic and thermodynamic mechanisms that determine this variability remain insufficiently studied. At the same time, due to the increased interest of this problem from various maritime institutions and sectors of the economy, hydrometeorological support for navigation, fisheries, mining, etc., the need for this kind of knowledge every year becomes all the more obvious. The aim of this work was to develop the theoretical foundations of the wave mechanisms of low-frequency oscillations of the level of the Sea of Japan on the basis of satellite altimetric data. The original part of this work is the study of the spectra of the natural oscillations of the Sea of Japan and resonant frequencies, as well as the description of cellular structure of the level field in terms of amplitudes and phases, and the development of the phenomenological and kinematic model of the translational standing waves that correspond to it as an alternative to the vortex hypothesis. And so this paper is it provides quite important contribution to the field. The experimental part of the work is every week we calculated at the step of 1/1/3 degree for the period of 1992 and to 2020, obtained from the Avisa data bank, was analyzed. The following provisions are made for. So the whole basin, deep water basin, was analyzed, and we looked at the cellular structure in the level field of the sea level of the Sea of Japan, determined by the results of statistical analysis satellite altimetry data associated with the dynamics of the translational standing waves. And the period that we looked at was from half a year to 2.5 years. And we analyzed the characteristics of interaction between the process of different timescales, and we looked at the temporal non-stationarity and spatial inhomogeneity of the oscillations, as well as significant concentration of energy in the deep water basins in the south of the water area. Conclusions are made about the presence of dominant seasonal fluctuations, their connection with the steric fluctuations as a result of warming up and cooling of waters, with the large-scale dynamics of the waters of the Sea of Japan, which is discussed in detail in Chapter 1. In view of the diversity of causes of the dominant seasonal fluctuations, their suppression is carried out by subtracting the average annual seasonal variation. This allowed basically to grasp the static levels change in accordance with the integrated equation of continuity of the continuity equation, and two types of data are taken for consideration. We analyzed the spatial distribution of phases with 0 degrees and directed changes of phases. It is revealed that the amplitude and phase pattern of the level oscillations obtained from Fourier analysis and mode decomposition resembles the position of surface thermal and dynamic fronts. In this quasi 2-year oscillation shows the position of the subarctic front, and therefore we support our hypothesis as about the multiple layer composition of the Sea of Japan. Well, the phenomenological model of gradient vortex waves with a horizontal and vertical mode structure processing the properties of both standing and progressive waves is proposed. and so there are traveling waves, amplitude and phase modulated by seasonal oscillations, which can complicate the overall spectrum of level oscillations. On the basis of the results, it is assumed that there are more complex waves with amphidromic points around which rotation of the level anomalies occurs. In the basis, and this the basin, the distribution is around nodes on the grid, and they can be identified through a divergential analysis of waves. A topographic capture of energy, shear and throttle waves, deflecting force of Earth's rotation, heat advection, nodal lines of seasonal oscillations at the border of the basin, and antiphase of 2.5-year oscillations revealed by the distribution of phase and amplitudes contribute to the rotation of anomalies inside the basin, with predominantly positive values at north and negative in the south, which are interpreted as convergence and divergence of total flows, rather than as mesoscale vortices. Based on theoretical conceptions and statistical data process, a new classification of low frequency wave motions on various grounds is proposed. And we looked at the waves that are 300 kilometers long. In the Tsushima, in the basin of Tsushima Lane, in the southwest of the Sea of Japan, the water dynamics, supposedly as a result of topographic capture, is realized in the form of two rotating dipoles. Systematized modern ideas about the region and statistical analysis of data only for the region of the basis are proposed. The possible connection with the seasonal rhythm of the flow of water through the Korean Strait and the change in direction of water flows with a period of about 2.5 years are shown, in addition to the presence of free oscillations of the same period. Topographic capture of energy, shear and frontal waves, deflecting force of Earth's rotation, heat advection, nodal lines of seasonal oscillations at the border of the basin, and the antiphase of 2.5-year oscillations revealed by the distribution of phases and amplitudes contribute to the rotation of anomalies inside the basin, with predominantly positive values at north and negative at the north and negative in the south, which are interpreted as convergence and divergence of total flows rather than as mesoscale vortices. There are similar features of the non-stationary spectra of both the level anomaly and the CBZ. A bond is obtained in the spectral region on a seasonal scale supported by a stable phase delay. A consistent hypothesis is proposed about the dependence of the low frequency level oscillations on the CBZ oscillations through parametric resonance, which is explained by the fact fact that the CBZ determines the change in the Coriolis parameter entering into the equation describing the law of planetary vorticity. The theoretical foundations of the proposed hypothesis and the equation of the elevation of the level are given with the change of its parameters in time. The detected level anomalies are characterized by the presence of nodal lines and progressive waves. A wave hypothesis is proposed according to which low frequency vibrations of the level of the Sea of Japan associated with the existence of translationally standing gradient vortex waves. According to the altimetric data, the Sea of Japan has a cellular structure and the hypothesis of low frequency wave that is associated with the vortex dispersion. A wave hypothesis states that according to which low-frequency vibrations of the level of the Sea of Japan associated with the existence of translationally standing gradient vortex waves. Their dynamics and kinematics are shown. Dispersion relations are derived on the basis of which the characteristics corresponding to the observed data is presented. A special case of hollow waves in the southwest part of the water area is described. Thank you very much. Questions for the speaker, please, for the defendant? Members of the Dissertation Council, please. While you are thinking, you just said that you looked at baroclinic and barotropic gradients of waves, and how did you account for the baroclinity in the equations? The baroclinic waves are observed with the condition of let me get back to my slides. The dispersion equation is based on hydrostatic equations including the rotation of the Earth, and we looked at the model of translational standing waves with a vertical component. And how did you calculate the baroclinity? Is it through the Rossby principle? The vertical velocity was presented in the equation of depth distribution, and this is equated to the equation of baroclinic waves, and so the inner radius, did you take the average in depth or the maximal value? We use average statistical changes. I have a question that with frequency spectra, directional spectra. So with this apparatus, what conclusions did you reach? Well, this apparatus is used in time scale orders in 3 points in order to perform spectral analysis, and its advantage vis-a-vis an ordinary spectral analysis is that the direction of the movement of wave fluctuations can be can be assessed in all directions, not only in 2 points, and we can calculate the 360 degree spectrum, and we can identify here the directional anomalies of wave character in the north part of in the west southwest go in the southwest direction. Any other questions? When you talked about the Tsushima basin, deep water basin, you said that there are Tsushima waves, or is it typical only of this deep water basin, or is it the Black Sea also can be equated to this? Well, every water basin needs special attention and special study, but every sea, including closed seas, is characterized by directional waves, and based on the topography of the Tsushima deep water basin, there's a probability that the same phenomenon can be observed in the Black Sea as well. I have a question that has to do with the changes, fluctuations over the whole period. Were there fluctuations more pronounced in some periods and less pronounced in other periods? I assessed linear and verbalic trends that concern the level of the sea, and there are additional assessments of the deep water basins, and there's a marginal fluctuation, and it's not very far from zero. As far as the spatial distribution, we see that some areas of the Sea of Japan, namely in the south, have some areas that have trends, either upward trends or downtrends. So there are no pronounced fluctuation changes, and so there are no. So the icy melting and changes, ice cap changes in this that we observe in the Sea of Japan don't affect this area. Well, there's some parts that are affected close to the seashore, especially in Russia, and that are affected by the. But as far as the Sea of Japan, the melting of the ice is not that considerable. It doesn't present any challenge really. So, Igor Valentinovich, please. I have a big question about the interpretation of these results using wave theory. How did you interpret the observations, especially in light of these oscillations, especially when you used sources or methods that, well, unfortunately I didn't understand the question. It was hard to hear. Could you please repeat your question, because it was not clear. There was a background noise. Do you hear me better now? Yes, please try. A little bit the same, but I have a question about the interpretation from the point of view of wave theory. The defendant showed that the long-term oscillations have a wave character. Thank you very much. I thank you for the question. The wave interpretation in my paper is based on a spatial distribution of phases of oscillations, and that is split and orthogonal functions. And as you see this slide, the spatial distribution of amplitudes and phases for the fluctuations of the level for half a year, 1 year, and 2.5 years. We see some areas with considerable density of phases distributed across the whole water basin, and it's interpreted as standing oscillations. We can see the average phase of two sides of these density areas. It changes about 180 degrees. In between these areas of density, we have directions of changes of the phases that can be interpreted as the distributed spatial fluctuations of the level, and the color shows that amplitude values, and the areas that are characterized by angles of standing oscillations are characterized as well by values that are close to 0. And within these closed and nominal areas, we see deviation from 0 values, and this allows us to interpret the oscillations within this time limits as wave oscillations that have the characteristics of both translational and standing waves. And we see some areas of closed anomalies that are highlighted, that are identified by statistical analysis through using different methods, are characterized by the density of isophases. Are you satisfied? Did you understand the question? Yes, I could hear it well. Any other questions? No more questions. Thank you very much. Anastasiia, Evgenievna, please take your seat. And the next item on the agenda is the reviews, including external reviews. We have 7 reviews for the work, 2 external, and 5 members, 5 from the members of the Dissertation Council, including the chairman, 6 positive reviews, and 1 negative review. All of them were uploaded on the website, and of course everyone could access them. And I would like to only read out the critiques in the positive reviews and dwell on the negative review in more detail. From the first one is from Bashmachnikov, associate professor of the Department of Oceanology. The review is positive, and the following commentary from critique to the structure of the work. The vendor could have united chapter chapter 3 and paragraph 2.6 because this is a logical follow-up, and Liger always also has some comments about methodology and the seasonal pace of the some of the in the poems that are connected with dynamic process, and therefore I'm not sure whether the conclusions of the analysis of non-filtered methods of observations. The defendant identified parabolic trends, and on page 44 the conclusions are made based on the spectral analysis of orthogonal functions. The analysis of orthogonal functions allowed making very interesting conclusions, and this is a big plus for the work, but we could be interested in more in-depth assessment of these conclusions. The next one is the methods that cover the connection between the rotation of the Earth and cross correlation and the oscillations of the level, because the order, seasonal order changes could affect this phenomenon, so we need some more in-depth study. The next external review comes from the head of the laboratory of large-scale changes of hydrophysical fields of the Shishov Institute of the Russian Academy of Sciences. The review is positive, but some content comments, some critique. The defects of the spherical nature of the Earth, identifying this phenomenon and the connection to the wave oscillations is very important contribution. But one climatic shift that took place at the turn of the centuries, and some sources cited there from by Lee, for example, that are represented in figures 2.3 and 2.3.2, and the work is written good language, but there are some typographical errors on some pages. Maybe the values are about exceedingly accurate, precise, and there are some pages that you cannot see the pictures very well. And the next review comes from the Department of Oceanology of St. Peter's State University. Again, very positive, but some critique. The first one is citing the results of wave vortexes are not related to the Fox publication of 2003. that have to do with the oscillations published in the cited book, but they are actually they come from Belenenko and Fox monograph of a different date. The next comment, the formulation Western oscillations is not very accurate. Why the sea is an indicator of climatic changes in the area? What is an indicator exactly? On page 33 it says the verification of the data in the Sea of Japan is carried out in Che and al. And Belenenko et al. But in reality, Belenenko of 2009, there's no verification, has no verification. And the velocity of the rotation of the Earth is cited, and the value is given. That is not very accurate according to Belenenko again, but this work doesn't really treat these rotations as stated in the dissertation. And also the paper states, the dissertation states that the oscillations have a dynamic character in a certain area. I don't understand this phrase and why the oscillations are excluded for the period of 2.5 years. And the next critical point, the phrase of semi-closed movement creates knots. Is not correct. And the formula of vessel brand minus is missing. And then the work of Belenenko et al. 2012 again doesn't have the treatment of waves that is stipulated by the author. And then also some dispersion results are not do not really follow, and there's something missing in the equation. Also, another page states that the anomaly of the level is characterized by extreme values in that stipulates that in the area of the Korean seashore has a certain character, but this statement should be justified because the figures don't justify that are provided that are supposed to justify that. The next, well, the external review is now over. The next external review is signed by Zimin, member of the Dissertation Council, Doctor of Geographical Sciences of the Institute of Sheshov Institute. The review is positive, and the following critical points are present there. Then the originality of the work states that there are no works in the Sea of Japan that relate to the Sea of Japan wave oscillations. It's not correct. Well, the lack of such works, if it exists, doesn't provide grounds for the statement of the originality of this work. The conclusions are quite valid, but the conclusions must be organized in order to address the goal and the task that are set before this study. And so the figures are numbered throughout, and the resultant work should be organized that relate to the figures that should be presented as a table that would facilitate the reading. Some paragraphs in the work are too small, and this rubrication that is, is such minute paragraphs also is not justified. Some figures are copy-pasted without special treatment, and some figures are not readable. Some symbols are overlapping, and for example, in one figure, and also there are some indexes. Index A is not analyzed, and I don't know where it comes from. And some figures says that the black lines refer to the sea, but these black lines also cover both the shelf areas and the onshore areas, and I don't understand why it happens. Figure 2.2 doesn't allow me to understand. The caption doesn't allow me to understand the description of all the figures, all the parts of the figures. Some captions miss very important information. For example, about the black line, about 95-degree interval. It's what is it about? Then the author presents classification of low-frequency waves, and this classification is not correlated to the works of all other authors, and doesn't allow us to assess its originality. And the text of the work has some lexical inaccuracies, citation. For these reasons, the C manifests seasonal changes, and the C that is the indicator of climatic changes. How can a C be an indicator of climatic changes? I don't understand. The changes in some areas is represented by the modes of three circulation modes. I don't understand how it can relate, and some formulas don't have some parts to them. One formula has no third part. The next review is signed by Doctor of Geographical Sciences, Evgeny Zakharchuk, Evgeny Alexandrovich, and the critiques are as follows. In the originality section, the defendant states that it's been identified, the non-stationarity has been identified for the first time. We should. I cannot agree with this. That this is the original point. And the last item on the in the section of the originality section, the Sea of Japan has oscillations that are in resonant relation to the other parts. This is true, but the resonant transfer of energy to the oscillations within the sea is, of course, an obvious thing, but it needs to, and therefore it doesn't provide for originality. Some figures have no explanation, and some statements are nonsensical, that the Sea of Japan is subtropical, in subtropical altitudes. This is not true, and I don't understand how the statistical analysis contribute to the to completion of the main goal of the work of assessment of low frequency wave oscillations. Some methods, some approaches are quite controversial. Paragraph 2.4. I don't understand what arguments help or are the basis for some methods and treatments and conclusions of the author. We have to have better arguments with detailed methodological descriptions of the approaches. Of course, low frequency waves waves are gradient, but not all waves. Some waves can generate like Kelvin waves, but they are not gradient. So some seasonal changes are correlated to the rotation of the Earth, according to the author, and some values then based on this correlation. And the subsections of 2.68 has a very weak connection to the paragraph 2.6, and the overview of the works of other researchers is lacking, really. The next review is by Klopatukin, Doctor of Geographical Sciences, the Professor of the Department of Oceanology, St. Petersburg State University. The review is positive, but the following criticism is there. We should have assessment of wave flows, not also for salinity and other parameters, and you could use the satellite observations for that. We also could benefit from empirical data assessment, data proofs of the models. The synoptic changes in the level of the Sea of Japan is correlated to the discrete discreteness of the data of the satellite data. The author also says that that there are no works that relate to low frequency wave oscillations. So what is new compared to what? The author says that a new atlas is presented, but how is it correlated to the old atlas is not clear. So it's not clear. The last review is by the member of the Dissertation Council, Doctor of Physical and Mathematical Sciences, Igor Valentinovich Polikov, representative of the University of Fairbanks, Alaska, the United States. The review is negative, and that's why I'm going to dwell in more detail on this. When analyzed the relevance of the topic, Igor Valentinovich states that the goal is relevant to the field when he analyzes the results, the statistical method, and the altimetric satellite data. The author analyzed the oscillations of the sea level. New features are identified, and they're important for the forming of the maximums over 1.5 year period, and this data is very important. This phenomenon is but there are some inadequate justification. Figure 2.5.1 that talks about the maximum values 2015 compared to the previous periods. The analysis of this correlation is not provided. The author attempts at interpreting the data of statistical analysis of the data of low frequency waves of standing waves, but these conclusions are not really justified, or I could agree with. The results of the statistical analysis of this satellite data in this basin is quite original. It contributes to our understanding of the complex dynamic of the Sea of Japan. And this approach is quite new, but it still needs sound proof. The overview of the situation in the Sea of Japan is not very original. If I looked at the text of the dissertation, unfortunately coincides with the text of other authors, and so these are direct borrowings. For example, by the dissertation of by Trusenkova, and some pages are cited, and some pages have less concentration, but up to 45%, and this is a very high value. As far as the paragraph about vortexes, the borrowings are up to 59%, come from a different source, and Belenenko's works is borrowed up to 66%. Our reaction is relatively neutral to these facts, but the author should be very attentive to citing other works and borrowing from other works. The significance of the work yields the following comments from me. The methods that are used according to the authors contributed to creating a new atlas of the Sea of Japan. This could be a very good practical contribution, but unfortunately this is not described in detail, and this atlas is not presented. So this is a very big drawback of the work. Some analyses are based on standard approaches, but some analyses are compromised by the author by omission of some values, and I have some questions for the defendant about the wave theory application to wave oscillations, and the last one critique. Three groups of critical points are organized into three groups. Some critical points are of principal character, and that mean that this defense should not be the basis for granting the sought degree, and other groups manifest that are of controversial discussion character. The first group includes the use of the term standing waves to explain the regeneration of waves is not motivated. You could use the Fourier equation to describe this process, and the next goal is for the use of this apparatus is to describe the mechanism of wave processes is too broad. It is too broad, and the application of this method is too broad. The approbation of the hypothesis in the paragraph 2.6 and deep water basins, the author identifies some characteristic frequencies, and the author makes the conclusion about certain anomalies, and this picture is interpreted in terms of standing translation and standing waves. Unfortunately, the text doesn't provide clear evidence whether an abstract scheme is the basis of the phase of the waves or concrete assessment on concrete images. So if it's an abstract scheme, so what is the relation of it to the observed data of the level of the Sea of Japan? And it also unclear how the wave theory approximates the data of the observations. As to the mechanism of the oscillation of the level, well, this discussion has to be accompanied by concrete estimates, and the orders should be in the sea, of the level of the sea, should be correlated to the shore orders. And so, of course, the complexity of the task thus increases, but it's necessary if the author wants to reach the task of that it's set for the work. And the seasonal rotation of the Earth that is used as the basis for some conclusions is not really a good basis. The equations that could be used are Mathieu and Phil equations, and that could prove that no parametric resonance is really relevant here. Section 2 has 75 pages, and section 3 they're different. The sections are too diverse in terms of sizes, and the logic is not clear in stating conclusions. Some information can be omitted without any damage to the content of the content of the work. Some data is excessive because it's not analyzed, it's just mentioned. Some works are only cited that the work so the author cites some works and saying that the analysis is described in this work and so on, but the work should be original and all the analysis should be spelled out in the text of the work. And so it's not a valid academic approach, really. So the text of the dissertation states that there's some errors in the analysis of the data relating to the area that is under study, but no analysis why the author considers them errors is provided. So the empirical orthogonal functions analyzed and the second mode is no more than the value of 8. This is a very controversial conclusion. And some examples are also cited. The author identifies the importance of the cones that are described in some, or that are depicted in some figures, but no analysis is really provided. The annual pace is filtration is analyzed through a velvet analysis, but the seasonal but if you look at the analysis, the conclusion is absolutely different, and the analysis needs more better ways of analysis, especially relating to progressive waves. And the text has no reference to the analysis of correlations. Only the ultimate conclusions are cited. The author has to provide the results that are clear, because this is one of the criteria for a successful dissertation. Because the results should be able to be verified, and so the following tests should be applied, including verification and reliability. The conclusions sometimes lack justification and argumentation, and some other comments on some pages. The average annual values of expectations in 1993 are attributed to 1993, although the date should be different. And the use of the term mathematical expectations is wrong in here in this text. On page 41, the author states that the values on the map are close to 0, but this conclusion is really trivial, and the some figures are described as that the conclusions are manifested by the analysis of the spectra, but no justification is provided. So also another conclusion of the spread of energy is non-linear. Again, it's a very controversial conclusion. On page 47, the direction is from the direction of wave distribution from east to west. Again, is not proved. So the author looks at low frequency waves, but the spectrum of low frequency anomalies is cut out, and why? And so some conclusions of statistical analysis about the cyclical character. Why is it non-linear? I don't understand. And some conclusions, some marginal errors are not described. And why the errors are marginal, I don't understand. There's no justification. And so, on some other, in some other passages, there's some nonsensical conclusions. Well, and some errors in equations. So. And some pages talk about some models that have to do with directional distribution, and this is not relevant to the topic of the dissertation. And why do we need this section? I don't understand. Some calculations are provided that of k, the equation is according to a standard approach. But what standard approach are we talking about? And the theory of turbulence in treating some data cannot really be applied. And some conclusions about energy flows have the inference has no direct link to the premises. So figure 2.6.21, the caption, it doesn't relate to it, and some sections have no relation to the work, to the topic of the work. So, and some conclusions about the mode structure is provided, but no data or evidence is provided. So, in light of the critical points, I'd like to concentrate on some original points. For the first time, non-stationary character of low frequency wave distribution is analyzed, and this is a trivial conclusion. The low frequency distribution, low frequency wave distribution of the standing waves is not analyzed through the correct observation methods. So no adequate empirical data is provided. So the diffusion process of wave distribution should lead to a spectrum of wave process, and according to the author, it should be done so, but unfortunately this hypothesis is not proved. So my conclusion is that the statements that are set out for the defense to be proven in the dissertation, only the first one can be conditionally accepted. Can we qualify this work as the one at the level of the candidate of sciences in view of the critical points that I made? My conclusion that my assessment is negative. So therefore, the dissertation of Anastasiia Evgenievna Zvereva doesn't meet the standards set out for the degrees of candidate of sciences at St. Petersburg State University, and that is my last review. And according to the procedure, we continue with the answers of the defendant for the questions. Please, Anastasiia Evgenievna. I would like to thank the reviewers for constructive critique, and I would like to group them into meaningful groups. And the first critical points that relate to the goals and the tasks and the used data. So the goal was to analyze the low wave oscillations in the sea of Japan, using the works of other researchers. I state that I can achieve this goal, and I don't analyze the flows based particularly, but I look at the average vertex values that are related to both convergent and divergent flows, and this allows me to make recommendations of how to assess low frequency oscillations in the Sea of Japan. And the discrete character of the satellite observations are the sound basis for my research. And an atlas was recently published by the Department of Oceanology of St. Petersburg State University, but the dynamic of Kurosiva wave flow is a new component that should be studied. The atlas doesn't use altimetric data and the statistical treatment of this data. But I use this data for the water basin of the Sea of Japan, and I use the works of other authors and that describe the baroclinic dynamic of the Sea of Japan. As far as the stationary and non-linearity, although it may look trivial, but the dependence of the statistical analysis provides the data for my conclusions about the non-linearity of the flows. And so the system of ocean to space, the processes of is also included, and the cascade mechanism of energy transfer is also accounted for. So the reasoning about the empirical theory of turbulence is applied to multi-directional wave flows, and the coefficient of between maximum and average values are applied to various periods, timescales, and the next group of critique is about the structure of the work, how the second chapter, maybe I should have subdivided chapter 2 into two chapters in order to delineate the different data analysis. In the paragraphs 2.6 and 2.68 provide data for the analysis, but they don't need a more detailed treatment and description. Some passages, some figures don't need detailed analysis. Some pictures, especially that relate to the Tsushima deep water basin, this is not necessary and not relevant to the work goals. Some pictures are not audible, but I provide in the apexes better resolution images so that the reader could refer to them at the back of the my work. As far as the citing of Belanenko, the borrowings are processed for plagiarism, and the texts are reformulated in order to meet the criteria of plagiarism, and so they're under the allowed limit. I treat the deep convection in some areas of the Sea of Japan over the last couple of decades. I use rigid calculation methods, estimation methods. It's just, I agree with the fact that the conclusions I make in the body of the text should be reiterated at the back after each chapter and in the conclusions. And this is my drawback. As far as the results, I can agree that the manner of providing these conclusions is too heavy, makes it hard to read the work. As far as the number of works, that it is inadequate. I say that the works that relate to the field of the is not adequate, and of course I didn't analyze what has been analyzed, so I just cited the results and that the treatments are present in those sources. I didn't have this as my task to analyze what has been analyzed. As far as the 5 modes, I say that unlike the first modes, the 4 modes have one order of values and that are less than 1%. So the 5 modes cover the whole volatility of the level of the Sea of Japan. So I say that that the changes in the level of the of course can be characterized by affected by moussons and climatic changes and I use these criteria. The deduction of seasonal range of the changes is used to provide the right conclusions. So the work also looks at the filtration of the modes and the splitting it into orthogonal functions. As far as the spectrum analysis, the wave is by definition is the fluctuation of the water in the water basin, and so Colomia and Cipollini study the chlorophyll field. So they identify the maximum periods and rhombic values. The character of low frequency waves and the types of these waves are understudied, and the energy of reflected waves should be less than the energy of the following waves. I presume that the overtones of standing fluctuations, oscillations, and the spectrum of the oscillations of the level is much more complex. As far as the resonance, in the case of low frequency waves, I produce a hypothesis that is non-contradictory, that has correlation between low frequency oscillations and the rotation of the Earth, and I use the Mathieu equation, and this process have a high degree of coherence, and of course is affected by the differences of amplitudes. As far as the energy, we could use the example of the swing, the children's swing. The amplitude is multiplied in the oscillation of the swing if the energy reaches a certain threshold level. So the same thing happens in the ocean. There is a number of works that state that the rotation of the Earth affects some natural process. Professors of Tokyo University, Shatake and Matasaki, use the grids of random contours. I use this data to assess low frequency oscillations and the Sea of Japan, and they connect this with the seasonal changes. And the last critique is about qualification. The works about this area take into account stratification of the waves, and but unfortunately they don't take into account the kinematic parameters, phenomenological parameters. And my classification, new classification, is a new classification of low frequency wave motions in the Sea of Japan. And of course, the vertical mode, as far as the maps of satellite data allow us to produce a grid of knots, and when we look at the classification, the conclusions are justified, because because, for example, one conclusion is about dissipating waves. And do you have any questions for Anastasiia, Evgenievna, and from the Dissertation Council members? No questions. Igor Valentinovich, do you have any questions? It's either I can ask many questions or no questions. I choose the second. Please speak slowly. I can either many questions or no questions. Unfortunately, we have a time constraint. Maybe a couple of 10. Parametric resonance. My question about it has been unanswered. As far as the quality of the analysis of the observations of the level, I have the same questions. I'm very pessimistic about the application of wave theory to this interpretation. You have to be very careful in using this theory in interpreting this data, and this is my main headache with this work. Other than that, I have no more questions. Thank you very much. Please take your seat, Anastasiia Evgenievna. Any questions from the audience, please, Vladimir Alexeyevich? Yes, please speak to the microphone. Valentin Alexeyevich Roshkov, Doctor of Physical and Mathematical Sciences, Professor of the Department of Oceanology, St. Petersburg State University. Please, Vladimir Alexeyevich. I would like to say that this is a tentative, that it was it was discussed at the department, by the department, and by the Academic Council of St. Petersburg State University. So in principle, that the work is not it has a controversial character, and some statements maybe not so rigidly justified, but this cannot be really cannot be treated as a drawback. As far as the non-troperant character of it, for geographers, many issues that are connected to the application of natural orthogonal functions to low frequency areas, wave areas. It's not used very often, but well, it was used in this dissertation. I think that the combination of geographical and mathematical methods maybe led to the non-transparent character of the work, because not geographers understand the specificity of mathematical methods, but it is in the work. I mean, they're cited in the work, and they of course need more elucidation. This is in the defendant doesn't have mathematical backgrounds, so she studied thoroughly this new area for her, and I think that she applied them by mathematics methods quite successfully and effectively. So I can say that that the defense for a geographical degree tells us that that this aspect is the main positive aspect in the conclusions, and therefore the dissertation deserves a positive assessment. Well, that's probably it. Thank you very much, Vladimir Alexeyevich. Dear ladies and gentlemen, the next section of our procedure is the academic advisor. Unfortunately, the academic advisor he is absent for health reasons, and he asked me to read the review. So I'm going to read the review of the academic advisor. As the academic advisor of the dissertation of Zvereva, Anastasiia Evgenievna, I know her as an independent researcher that is versed in the modern mathematical methods, analysis methods, and geographical background. Zvereva Ekaterina, Anastasiia, sorry, Evgenievna, sorry, he made a mistake. Graduated from the University of St. Petersburg in 2012 with a degree in astrology, and she has certificates of English language proficiency and Japanese language proficiency that allows her to follow the literature in those languages that relate to the Sea of Japan. She also graduated from a postgraduate course and passed all the required examinations, and she published the results of her research in different proceedings of different conferences, and presented her work at different conferences. Her publications include Scopus Index and Web of Science indexed publications. She's been a member of the working groups that's worked on issues supported by different grants, which also talks highly about the expertise of this author. The conclusions are original and are derived from independent work, and they're practically significant for the navigation and fishing in this area. They account for the regional characteristics of the Sea of Japan in terms of low frequency wave oscillations, but also take into account the global patterns of low frequency oscillations. That also she talks about horizontal and vertical structures of amplitude distributions. She set ambitious goals and uses complex analysis, Fourier analysis, and other methods. She uses stochastic modeling to spatial distribution. I have no hesitation to state that the work of Anastasiia Zvereva meets the required standards of St. Petersburg State University, and Anastasiia Evgenievna Zvereva deserves being granted the degree of Candidate of Sciences of Geographical Sciences, signed by Professor Emeritus of St. Petersburg State University, Fox Albert Fox. And according to the procedure, we have a 10-minute break for the Dissertation Council to discuss the dissertation and the verdict. Please, those who are not members of the dissertation, may you leave the room, and you will be invited back when the discussion is over. Dear ladies and gentlemen, esteemed colleagues and guests, as the chairman of the Dissertation Council, I announced that we've voted, and out of the 5 members of the Dissertation Council, 4 voted for the positive verdict, and one member voted against it. So the decision, the resolution to grant the degree of geographical sciences is granted to Anastasiia Evgenievna Zvereva. No, we need to vote. So we switched off the. So let's vote again. Vote. Belanenko 4. Lopatuhin Leonid 4. Zemin Alexei Vadimovich 4 for the verdict, and the member of the unfortunately against, and Sakharchuk against. I'm for the verdict. So the decision is reached. Thank you very much. We have the concluding statement of the. Thank you very much. I would like to express my gratitude for the time that the Dissertation Council members reviewers took to analyze my paper, and I will take into account these critical remarks in my future work. Thank you very much. Please take your seat. Therefore, the session is closed. Thank you very much for participation. Please switch off the broadcast. Thank you. Thank you.